Okay, last one. I want to get a hyperbola. So what you're going to do is you're going to group the x squareds, the x's, group them, plus group the y's. Oh wait, no, I'm going to put 0y for now. I'm going to move the 72 over. I'm going to move this over outside of it. So there's no y to combine with this one. So I put a 0 for now, but we're going to ignore that in a second here. Here, don't we have to pull out a GCF? Like over here, remember this one? Pull out a GCF. So I'm going to pull out the -4, leaving me x squared. And when you pull a -4 out of here, that leaves you with a -6x plus something. Plus, I'm actually just going to leave -y squared alone. It's pretty nice. Equals 72 plus something. Now, how do we find out this blank? Well, what's half of -6? It would be -3. -3 squared is 9. But over here, it's -4 times 9, so this is -4 times 9, which is -36. So it looks like I'm going to have -4. And when I factor this, I'll get x minus 3 squared. Here I just have 9y squared, which is actually kind of nice. And here that's -36. 72 minus 36 is positive 36. Okay, we know it's a hyperbola, so I have to divide by 36 because it has to equal 1. And when I do that, my answer is, wait, in a hyperbola, isn't this part supposed to be negative and the negative's there? So this is going to be kind of tricky, but I'm going to have the y up front. So it's going to be y squared, and 9 goes into 36 4 times, so it'll be 1/4. So you just do that. And then the other one, minus, because this is minus, I'm moving. And this is x minus 3 squared. And 4 goes into 36, this is 1/9 equals 1. Again, I put the y first because I need the minus in between. Remember, hyperbolas always have a minus between. Okay, from there, I need to know my center. Well, your center, well, isn't it going to be xy? So isn't your x, the opposite of -3 is 3, and y, isn't that y plus 0? Which is kind of nice. That's just y plus 0. So my center is over 3 up 0. There's my center right there on the x-axis. Okay, I want to graph this. Well, looking at the values, what I'll notice is a 4 for the y. So what that means for y value, I'm going to go up 2. So half of you square root 4. So what you're going to notice is a is going to be plus or minus 2, and b equals plus or minus 3. So your a value is 4, so it goes to the y, so you can go up 2 and down 2. For the b, you're going to go out 3 and out 3. And then for a hyperbola, what you do is you create a box. Because from that box, you're going to create an asymptote. You create asymptotes. And then from those asymptotes, the whole point is you're making these asymptotes. From these asymptotes, you know the y is first. If x was first, you go left to right. But since y is first, it's going up and down. So what you do is you bring your hyperbola along that, hit this, and turn back around. And then this one is going to go along this, hit that point, and then turn back around. That would be the graph of your hyperbola, hitting at the vertices. And then how do you find your foci? Well, your foci is c squared equals a squared plus b squared. So it looks like c squared is going to be 4 plus 9. So c is going to be approximately the square root of 13, which the square root of 13 is about between 9 and 16. It's pretty close to 2.5. So you're going to go up 2.5 and down about 2.5. It's not too far up or down. And, oops, I said that wrong. That's 3.5. I messed up. About 3.5. So actually, 3.5 is a little bit farther down, more like right down here and right there. Anywho, those are my foci. So if I want to write those as coordinates, what we basically are going to have for your foci, well, for the first coordinate, the x value doesn't change, so it's going to be 3. But you're going to be up this 3.5. And the other one is still at 3, but you're going to be down 3.5. Because you went down 3.5, you went up 3.5. Those are your foci.